So completing the squares and sketching quadratic functions. Now we know that a quadratic function has the general form f of x being equal to ax squared plus bx plus c. That's a general form. At times you might not have this portion. That doesn't disqualify it from being a quadratic function. So basically, for it to be a quadratic function is that the highest power of x should be power 2. Then it is quadratic. Now, when you are sketching a quadratic function, if you have got a quadratic function f of x which is equal to x squared, you need to know this one is just simple. If this is the x-axis, there is the y-axis. This graph was going to go like that. It's going to pass at 0, 0, and then it goes up like that. This is for f of x is equal to x squared. Now, if it becomes f of x is equal to, you put a negative and then it is x squared, then it means that this function is going to tend towards the negative values of y. Okay, it was supposed to be towards the negative values of x or positive values of y, but because of that negative, it tends or changes direction, so it goes down like that. Okay, so that is a quadratic function that goes down when it has got a negative in front. So now every time that you see that something has got a positive here, the number in front of x squared is positive, just know that that function is going to have a minimum. That's what we mean by minimum. It forms a curve up. Okay, when it has got a negative, it means it's going to have a maximum. So when this function becomes f of x being equal to, let me say, negative 2x squared, this 2 doesn't change anything. It will just affect how much widening it is. It is just going to affect if it is going to widen more or it's going to widen less, like that. But the same thing is going to pass at the same point, 0, 0. So that is what this constant in front represents. Now let's say we've got negative 2x squared. Now I add the constant. Any constant, let me say I add the 4. How does that 4 affect? Remember, I've said this negative 2 will necessarily not affect anything. It will just affect how the function widens. So that constant 4 that you have added to the function is going to shift the graph in the y direction. So instead of you starting at 0, you are going to start at 4. Now remember, there's a negative in front here, right? Meaning that it's going to tend down. Okay, so this function is going to go like this because of the 4 there. So that is how it gets to change direction. What if it was f of x being equal to, let's say, let me say 3x squared and then minus 5. How does the function change? So for this function, instead of it starting also at 0, 0, it's going to go at negative 5. Okay, but notice that this function has got a positive number in front, meaning that it's going to tend upward. It's going to go upward. So this function is going to go this direction like that, and also this direction like that. So this is how the function is going to be able to go. So we are able to find these values here. These are called x-intercepts. And x-intercepts, these are just points where the graph cuts the x-axis, and that happens when y is equal to 0. So just equate this function to 0, and then you are going to be able to find those points. Okay, now what happens when you get to add or subtract a number to the x? So for example, you have got, let's say, x minus 2, and then this is raised to the power 2. Okay, like that. So for such a function, what you are going to do is you are going to equate what is inside the brackets there to 0. You are going to find a positive 2, meaning that you've shifted your graph to positive 2. And because you can see that x is positive inside here, meaning that it's going to go up. Okay, to now 10 and go up like that. So that is how it's going to go. Now to find where it is going to cut the y-axis here, you are going to equate x to 0. So it means, yes please, there is a question?
Sir, but what was it where it is x minus 2 squared? You start by expanding. Then that's when you do the graphing part.
So that would be complicating your life, because if they've expanded something, they ask you to sketch, you have to express it in this form. So that is the part for completing the squares which we are going to do.
How is it complicating my life? Because we'll find there a constant while there's a single x that is squared.
All right.
We also find either positive or a negative on the x squared, then we know what to do, right?
You are going.
Rather than really.
Okay, you are going to see what I mean. So again, when you have got, let's say, f of x, maybe let's say it is equal to, we have got, let me say we have got 4, and then minus 3x, and then squared. So for such a function, get what is inside there, equate it to 0. So if you equate 4 minus 3x to 0, you're going to find that x is 4 over 3. So at 4 over 3 here, okay, at that point, now you can see that the number in front of x is negative, meaning that the graph is going to tend towards the negative values. So for this function, it's going to tend down like that. That's how the function is going to be going down. Okay, now what if you have got a combination? You have got a number that you've added to the x, and also you have got a constant. Let's say you have got a function f of x that is now in the form a open brackets x plus p closed squared plus d. How do you sketch such a function? So for example, I can give you f of x that is equal to, let's say we have got a 2 open brackets, you've got x, let's say minus 4, and then squared, you have got a constant 3. So how does this change the function now? So the constant 3 that you are seeing, which you've added to the function, that is going to shift the function in the y direction. In the y direction, meaning that the function is going to go at here. Okay, oh sorry, this is a 3. And then if you get to equate what is inside the brackets to 0, you're going to find a 4. Okay, so this 4, this tells you that the function has been shifted towards 4 in the x direction. So the function is going to start at this position here, okay, at this position. Now you can see that this number in front of x is positive, or just look at x itself here is what? Positive. Meaning that the function is going to go up. So the function is going to be going like that from that point. Okay, so if this was a negative 2, meaning that the function would have turned down like this to have the maximum. Yes, Richard.
Yes, can you repeat that statement again?
Okay, so when this number in front is positive, or just the x itself here is positive, meaning that the function is going to go up, like going to open up when it's positive. It's going to be going towards the positive values of y. But if it becomes negative, it's going to be going towards the negative values of y. Please take this principle for all the functions that you are going to be doing, like the radical functions, rational functions, modulus functions. I'm going to mention the same principle. Alright, so that is how it's going to go. So basically, this is how you get to sketch quadratic functions. Okay, that's how you get to sketch quadratic functions. Now what is going to be important is, if they've given you a function that is not in this form, look at this form that I've written here. Okay, this form, you have to express it in this form. And when you express it in this form, this is what we call completing the squares. Now remember, I said for you to find the turning point, you are going to equate this which is here to what? To 0. It is the same as just changing the sign of this number which is here, right? So the turning point of a quadratic equation, you get this value which is here, change its sign. So that will be negative p, comma, and then you get this number which is here. Don't change its sign, comma d. So that is the turning point of a quadratic function. Negative p, comma d. Okay, or just equate what is inside there to 0, comma what is outside here. Yes, Martha.
So I do even change the sign.
Because you are equating to 0, when you equate something to 0, consider, let's say you have got 4 plus x. Okay, you've seen that 4 here is positive. So when you equate it to 0, what do you expect to find the value for x? Is it going to be positive or negative?
Oh yeah, it's going to be negative.
Yes. Okay, now let's say we've been given a function f of x which is equal to x squared minus 2x and then plus 3. You can see that this function is not in the form that I wrote, ax plus p squared plus d. Okay, so how do you get to sketch it? First thing first, this function, you need to make sure that you express it in the form a open brackets x plus p squared plus d. Like, just complete the squares. That is what we call completing the squares. Now, to complete the squares, the simplest method you are going to find, I think, which few are going to talk about, please make sure that there is a 1 in front of x squared. Always, not a negative 1, a 1. And it should be positive 1, please. Okay, since there is already a positive 1 here, what am I going to do is, I'm going to write a bracket there. I'm going to write x. Please don't put a square. And then I'm going to get this number that has got x, not x squared, that has got only x. Okay, I'm going to find the half of that number. The half of 2, we know that's a 1, right? But there's a negative there, so write negative 1. And then I'm going to put a square. Alright, after putting that square, and then please always put a minus here, always a minus. Get this number which is here, square it. 1 squared, that will give you a 1, write it here. So this portion that I've written here is the same as from here up to here. And then I'll write the 3 at the end, plus the 3. So what I've done here is I've completed the squares. Yes, Martha?
Wait, that one from the x, it's the one that is written there as minus 1.
Yes.
Yes.
The minus 1, you've gotten this one, you square it. That is what gives you this number which is here. So this is what we've done. We've completed the squares, and then I can easily sketch this function. How do I sketch it? You can see equate what is inside to 0. Just change the value of this number inside. That will become a positive 1. This will be positive 1, and then positive 2. So this will be the turning point, okay? And then you can see that x is what? X is positive. Meaning that the function is going to be going up like that. And where is it going to cut the y-axis? That is called the y-intercept. Y-intercept is just this constant you see here. That means it is going to cut at 3. So if you do this, you've gotten all the marks. Okay, for this function, there are no x-intercepts. There are no x-intercepts. It doesn't cut the x-axis. And the reason for that is because the discriminant b squared minus 4ac is less than 0. Like, b squared minus 4ac is going to give you a negative value. Remember we said when b squared minus 4ac is less than 0, that is going to give you 2 complex roots. When you have got complex roots, it just means that you don't cut the x-axis. That's the meaning. You don't cut the x-axis. But if you cut the x-axis, it means that you have got 2 real roots. If you cut the x-axis at one point, just like this, it means you have got 1 real root. But if you cut the x-axis at 2 different points, like this, it means you have got 2 real roots. Okay, but for a question like this one, you don't have any real root. You have got complex roots. You don't cut the x-axis. Okay, so that's the first one. Let me look at another one. What if you've been given f of x being equal to, let's say, 2 minus 4x minus 3x squared? They've asked you to complete the squares and therefore also get to sketch. Now, first thing first, express it in the general form. Start with the one with a squared. Okay, so this is going to be, I'm going to write the one with a squared, and that is obviously this one. Please get with a sign. That is negative 3x squared, and then get a negative 4x, and then get a positive 2, okay? Like that. And then from here, always make sure that the number in front of x squared is a 1. So since it's not a 1, I'm going to factorize out this first 2. Please just factorize out the first 2. It will be much easier. Okay, just the first 2. So I'm going to remove a negative 3, and then what will remain with is x squared. Now remember also here I've removed a negative 3. So what we are going to remain with is a positive 4 over 3x. And then you have got a positive 2 at the end. I don't know if this is okay. If you multiply back this one and this one, you'll still get back the 4x. Are we good up to here? Yes, Richard.
So is that a shortcut?
I presume
Okay, okay.
you, yes, you can go on because
Because the procedures that have been taught you is you follow the procedures from there. You factorize it into
I, 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 I
two.
I know what you are talking about. Please, don't actually forget about that long method. Going in wrong a long method will not make you get to earn a lot of marks. So this one is much direct and simple instead of factorizing like all the three. And no one is going to penalize you because you factorize the first two. Okay? No one is going to remove some marks because you didn't factorize everything. No. Okay.
Okay, sir.
Now when you reach at this point, see now you've got a number in front of x squared is a 1. And then I'm going to write a negative 3. Please, I'm going to put a big bracket. Okay? Like that. And then I'll put a small bracket inside. Instead of writing x squared, I'll just write x. And then I'll get the sign which is here, that is a positive. Okay, that is a positive. And then I'm going to find the half of this number which is here, 4 over 3. What is the half of 4 over 3? Let me see, people know mathematics. The half of 4 over 3?
4/6.
Correct. 4 over 6, which I can also write as 2 over 3. Okay, just multiply the denominator by 2 if you want to find the half of a number. Okay, which is the same as 2 over 3. And then I'll close. I'm going to put a square. Please, I said always subtract. Okay, always subtract. And then I'm going to get this same number which is here. You see that I didn't include x here. Okay, I didn't include x. I'm always going to subtract, and then I'm going to get this number, I square it. So 2 squared, that will give us a 4. 3 squared, that will give us a 9. And then I'll close. So this thing that you're able to see inside here is the same as this thing that you're able to see here. You can just go, like, when you are free at your own time, expand this and subtract. Yes, please.
No, this volume. Okay, so why did you write the -4/9?
So as I have said, please always subtract. Always subtract here. I don't know if you remember what we are doing last time when we said what's the identity for a squared plus b squared. What did we say? The identity was what? A plus b squared minus 2ab. I don't know if you remember something like this when you're talking about roots of a quadratic. So the question is, why are we subtracting here? Why are we subtracting? It has to do with this same question.
Okay, thank you.
All right, good. Okay, and then we're going to write these two at the end. Yes, Paxin.
Sir, sir, I see some that they don't know if it's jump to the other side and then they calculate how is that.
Uh-huh. So that's the method I want you to avoid using, where they'll tell you, no, this thing goes the other side, like the one mostly they taught in high school. In high school, they confused me in such a way that I never knew how to get to complete the squares, because they were saying, no, you take this one, it jumps the other side and such things. Please, for jumping the other side, that is basically when you are solving an equation using the completing of the squares method. But this is a function, it's not an equation, so there is no jumping over the other side. All right.
So there's a point where we just need to jump.
No, forget about the jumping. For here, it's not necessary. Okay, when you reach at this point now, I'm going to now distribute this negative 3 to everything inside here because it applies to them all. That means that if I didn't put these big brackets, the answer is going to be wrong, because it means that the negative 3 will only apply to this portion. Okay, so I'm going to multiply, so it become negative 3, open brackets, x plus 2 over 3 squared, and then negative 3 multiplied by this. What are we going to get? That will be positive 4 over 3, right? Plus a 2. Okay, and then from here, this will be negative 3 x plus 2 over 3 squared. Now we add. Of course, 2 over 3, I can multiply on top by a 3, even down I'll multiply by a 3. I have not changed anything. 3 over 3 will give me a 1. So my aim is just to make the denominators the same so that my working is going to be much easier. Since the denominators are the same, I'll just write the 3 in the denominator. And then on top, I'm just going to add 4 plus 6. Okay, that gives us a 10. So meaning that the turning point for this quadratic is going to be at, you get what is inside the brackets, to change the sign, negative 2 over 3 comma 10 over 3. So we can sketch this function.
That's why.
Yes,
So why
please.
is it 2 multiplied by 3 over 3? Me and lost.
Okay, just forget about this. Just make this as a single fraction. 4 over 3 plus 2. That's what you do. So the x value is at negative 2 over 3. Then the y value is at 10 over 3. So at this point. Okay, now if you see this value is negative, meaning that you are going to have what? A maximum. Like the function is going to be going towards the negative values of y. It's going to go like this. To go something like that. Okay, this should tell you that this is a constant. That is a y-intercept, meaning that the graph is going to be cut at positive 2. Okay, positive 2. Meaning that if you draw the graph like this, it comes and cuts the y-axis at a negative value, then it's wrong. Because the y-intercept is supposed to be a positive 2. Okay, and then you are supposed to find these values. This value here and this value here. These are the x-intercepts. Actually, when they ask you to solve an equation, these are the values that you find. If they've given you a quadratic equation to solve, all you find are the x-intercepts, because you take as y is equal to 0. Like you are going to say 2 minus 4x minus 3x squared is equal to 0, meaning that y is equal to 0. Okay, are we good at this point? Yes, Paxen.
Yes.
Okay.
Sir,
Yes.
I don't know if you divided negative 3 into 9 need to give you that 3, so I'm asking if you can explain more this
So,
part.
so I multiplied this negative 3 by negative 4 over 3. I mean by negative 4 over 9. We know that 3 can go here one time, 3 can go here 3 times, like that. This negative will cancel with this negative. That's what I did.
Oh, sir, why didn't you cancel also the 3 in front?
No, this 3 will multiply this, and then this same 3 will also multiply this. So when this 3 multiplies this first thing, that is what you are going to see here. And then when the 3 multiplies the negative 4 over 9, that is where you're going to see this one here. Is that okay?
Yes, sir.
Alright. So I think I've spoken enough. Now we can look at exam practice questions from just the recent exams for this year. I'm using these questions are from exams, University of Zambia this year and last year. Okay, question 1. Consider the quadratic function f of x is equal to 2 minus x squared. Express f of x in the form f of x is equal to a x plus p squared plus q, where a, p, and q are real numbers. Sketch the graph f of x, clearly indicating the x and y intercepts and the turning point. So first thing first, we need to complete the squares. Express f of x in the form, meaning that we have to complete the squares. Now if I wanted, I could have used a relationship, okay, of just relating this equation with this equation. I would have found those. Martha, you have a question?
So I've got a question. What of that other formula, chat? Why they tell you to find the turning point? Just
I'm going to I'm going to tell you about that.
oh, but they're also okay.
Yes, I'm going to tell you about that. But most of the questions that you are going to find here, they are first going to ask you to complete the squares and then you sketch. So you are going to find little or no question where they go direct and say sketch without you completing the squares. Okay, so this question, I'm going to write it in the general form. I'll start with the one with a squared. Remember, it has got a negative, so that will be negative x squared. And then you have got negative x, and then you have got a positive 2. So completing the squares, remember this one has got a negative in front, so I'm going to factorize out that negative. And I'm going to factorize the first two. Okay, the first two. So that will be negative, open brackets, x squared, and then this one will be positive x, and then positive 2. And then from here, I'm going to say negative, I'm going to put a bigger bracket, okay, and then a small one inside. I'm going, instead of writing x squared, I'll just write x, and then plus. I'm going to get the number in front of x. We know that is a 1, right? And then I find therefore of 1, that is 1 over 2, okay? And then I'm going to square. And then I'll say minus. Always put minus. And then whatsoever is here, 1 over 2, square it. That is going to give you 1 over 4. Then I'll close. And then I write the 2, which is a constant outside there. And then I'll distribute this negative to the inside. So that is going to be negative, open brackets, x plus 1 over 2 squared, and then the negative times negative 1 over 4, that will be positive 1 over 4, and then plus a 2. Now friends, 2 is the same as 2 over 1, right? My aim is just to make the denominators the same. So how can I make the 1 in the denominator the same as 4? So I'm supposed to multiply by 4, but I shouldn't do it just down. I'm going to multiply on top by a 4. I also multiply down by a 4. So that 4 over 4 is still a 1. It will still give us a 2. Okay? So this is going to give us negative x plus 1 over 2 squared, and then plus. Since the denominator is the same, I'll write it. And then 1 plus 2 times 4 is 8. 1 plus 8, that is a 9. So meaning that for this function, the turning point, who is going to identify the turning point? Paxin.
So it's in negative 1 over 2 plus 9 over 4.
Instead of plus, it's comma, right? Comma 9 over 4. Okay, this is the turning point. Now, we have found the turning point. The next thing that I want to find is the x and y intercepts. So, who can help us? How can we find x intercepts? Where the graph is going to cut the x-axis. How can we find those?
So you equate that equation to y is equal to 0.
Okay, you need to know for x-intercepts, y is always equal to 0. Alright, y is always equal to 0. Now, I can, if you want, equate this to 0, or if you want, get this one, equate it to 0. It's your choice, friend. It's your choice. Okay, but mostly this one is going to be much easier. But even this one is okay, because you just look for the product and the sum. Okay, and then you start doing that. But I'm going to use this one to find the x and y intercepts. So I'm going to equate f of x to 0. So meaning that where there is f of x, I'm going to put 0, because f of x is the same as y. So I'm going to say 0 is equal to negative x plus 1 over 2 squared plus 9 over 4. And then I'm going to get this, take it to the other side of the equation. Okay, that becomes x plus 1 over 2 squared is equal to 9 over 4. And then from here, I don't want this square. I'm going to square root both sides. Okay, I'm going to square root both sides. So I'm going to remain with x plus 1 over 2 is equal to, remember when you square root, you are going, square root of 9 is a 3, square root of 4 is a 2. You are going to get positive, or again I write x plus 1 over 2 is going to be negative 3 over 2. Like when you square root, the answer is either going to be negative or positive. I hope this is not confusing. And then I'm going to take the 1 over 2 the other side. So x is going to be 3 over 2 minus 1 over 2, or x is going to be negative 3 over 2 minus 1 over 2. So here x is going to give us, since the denominator is the same, we'll just say 3 minus 1, which is a 2. 2 over 2, that will give us a 1. Or x is going to be, since the denominator is the same, I'll just say negative 3 minus 1, that's negative 4. Negative 4 over 2, that's negative 2. So these are the x-intercepts. So x-intercepts, we have got 1, comma, 0, and negative 2, comma, 0. Why am I saying comma 0? Because y is 0, we said y should be 0. Now that we have found the x-intercepts, the next thing we need to find is the y-intercept. And friends, we know that y-intercept happens when x is equal to what? Mr. Richard, when x is equal to what? When do you find the y-intercept? What should be the value for x?
0.
Yes, x is 0. Okay, now for the y-intercept is so simple. You just get the constant which is here, because you say y is going to be equal to 2 minus 0 minus 0 squared. So y is going to be equal to 0. So this is going to be, when x is 0, y is going to be 2, not 0. Y is going to be 2. Okay, so we have found all the critical points. Now we can easily sketch the graph. So I can now remove this. So x-axis, our y-axis there. I'll just get the critical values that we have found. We have found 1 comma 0. So let's say this is 1 comma 0. If this is negative 1, this is going to be negative 2. We also have negative 2 comma 0. And then we also have 0 comma 2, meaning that we also have a y value being 2. So if this is 1, 2 is going to be somewhere here. And then the turning point, we have got negative 1 over 2. Okay, if this is negative 1 over 2 is half of that. It's going to be somewhere here, the middle. And then 9 over 4, going into 9 one time, 2 times, remainder 1 over 4. So 9 over 4 is the same as 2, 1 over 4. So that number is so near to what? Is so near to 2. So it's going to be somewhere above 2. Okay, not so much above, but just somewhere there. So this is where the turning point is. And you know that the graph is supposed to pass through 0 comma 2, which is here. We know that the graph is supposed to pass through 1 comma 0 and also through negative 2 comma 0 there. What remains? Just join those. So it goes like this. And then this side, it also turns and goes like that. So here is a quadratic. Now because this point, you can't clearly see it, like you can't clearly see the values, because like I'm using a sketch, just point there and write and show that that is a negative 1 over 2 comma 9 over 4. Otherwise, for some people, they can remove some marks for you if they don't see the turning point. So here you've clearly labeled, you've gotten everything. Is this okay? And you can clearly tell when we completed the squares, we found this as negative, meaning that the function is supposed to point going towards the y values which are negative. That's why the function is going down, having a maximum. Are we good? Are we good?
Yes, sir.
Now we are going to talk about absolute value function. Now imagine they said sketch the graph of f of x, and then they put these lines. That is absolute value. When you hear absolute value, you don't want anything negative. Okay, you don't want a y value to be negative, any y value which is negative. So instead of your function going down, this portion which goes down, you're going to turn it going up like that. This portion which goes down, you're going to turn it going up like that. So the function is going to be, you go like this, and then you turn, you go up, and then you go down like that, and then you go up. So for absolute value functions, which are for quadratics, just sketch the quadratic the same way you're supposed to sketch it, but any portion that is going to on the negative portion, you are going to remove that. And then you turn the function going in the other direction. It should go up instead of down. So that is if it was absolute. We are going to see some of those questions. Okay, let's consider this one. Consider the quadratic function f of x, which is 2x squared plus x minus 3. Express f of x in the form f of x is equal to ax plus p squared plus q. Okay, also sketching the function and getting clear the x and y intercepts, and also the turning point. So we get f of x. This should be equal to 2. Actually, there is a negative in front here. Now, since we've solved something with a negative, let me make it positive here. Okay, 2x squared, and then minus a 3. Oh, that is plus x first. and then minus a 3. Now since the number in front of x squared is not a 1, I'm going to factorize out that. So I'm going to factorize out 2. I'm factorizing out the first 2. That will remain x squared plus what will remain here is 1 over 2x. Okay, and then minus the 3 at the end. From there, I'll write 2, a bigger bracket, and then a smaller one inside. Instead of me writing x squared, I'll just write x. And then I'll find the half of half. What is the half of half? Anyone? What is the half of this number? That's what?
1/4.
Yes, that's 1 over 4.
And
Now remember, put a square there. Please always subtract, put a minus, and then you get the same 1 over 4 square it. That will give you 1 over 16. And then you close. Minus 3 at the end. And then distribute the 2 now. This will be 2, open brackets, x plus 1 over 4 squared. And then 2 multiplied by 1 over 16. That will be 1 over 8 because 2 can divide into 16 8 times. And then minus a 3 at the end. To just make the denominators the same, I'll multiply on top by 8, even down by 8. So this is going to give us 2x plus 1 over 4. I'm doing this because we don't use a calculator in mathematics. Okay, since the denominator is the same, I'll write it down. And then if we multiply 3 by 8, is that 24? So I've got negative 1 minus 24. That will give us negative 25. Okay, don't write again in negative. The negative is already here. Okay, so meaning that the turning point for this function is at negative 1 over 4, comma, negative 25 over 8. And then let's go on and find the x and y intercepts. Okay, starting with the x intercepts. Now these are not going to give you like definite values or something like square, perfect squares or something. They might give, okay, I've seen it, they might give. So for the x intercepts, y is supposed to be equal to 0. Now it's your choice whether you want to solve this one from here or you solve it from here. It's your choice. I'm going to solve the one down. So I'm going to say 2, open brackets, x plus 1 over 4 squared minus 25 divided by 8 is equal to 0. I equate it to 0. And then I'll take the 25 over 8 the other side. So that is going to be 2x plus 1 over 4 squared being equal to 25 divided by 8. I don't want these 2 in front, so I'm going to divide both sides by 2. So I'm going to remain with x plus 1 over 4 squared, and that is going to be equal to 25 over 16. Like dividing by 2 is the same as multiplying by 1 over 2. So if I multiply this 2 with this 8, that is what gives me 16. Then from here, I'll square root both sides. So I'm going to get that x plus 1 over 4 is going to give us square root of 25 is a 5, square root of 16 is a 4, or the same x plus 1 over 4 is going to give us negative 5 over 4. And then take the 1 over 4 the other side. That will be x is equal to 5 over 4 minus 1 over 4. Or x is going to be negative 5 over 4 minus 1 over 4. So this will give us x being equal to, since the denominator is the same, we'll just subtract 5 minus 1. That will be 4. 4 over 4 is a 1. Or x is going to give us negative 5 minus 1, that is negative 6. So that will be negative 6 over 4, which is the same as negative 3 over 2. So those are the x-intercepts, 1, 0, and negative 3 over 2, 0. After finding that, you also find the y-intercept. Y-intercept happens when x is 0. Just get this constant. That's the y-intercept. Okay, so that is 0, negative 3. When you get to put that, you can now sketch your function. x there and y there. Okay, so from here our critical points, we have got negative negative 3. It means that negative 3 is here, then negative 2 is going to be here, negative 1 is going to be here, and then we also have positive 1. We also have negative 3 over 2. Now negative 3 over 2 is the same as negative 1.5, so it will be somewhere here. Okay, I'm going to put here negative 3 over 2 comma 0, positive 1 comma 0, and then we have got negative 0 comma negative 3. So this is negative 2, negative 1, negative 2, negative 3. So we also have this coordinate here. And then the turning point is at negative 1 over 4 comma negative 25 over 8. Now 25 over 8. How many times can 8 go into 25? That is about 3 times. Remember 1. So that is just approximately above a negative, below a negative. That is going to be negative 25 over 8 is about negative 3, 1 over 8. That is so near to negative 3, but see, a bit down here. Okay, the x value is negative 1 over 4. If this is negative 1, negative half is going to be the middle of negative 1. And then negative 1 over 4 is the middle of negative half. So it will be somewhere there. So this point we're talking about is going to be somewhere here. Okay, there. And then you can sketch. So remember, supposed to pass at 0. This is the turning point. It's supposed to pass like that. It goes up. And then this side after the turning point is supposed to go like that. So that is the graph, and you know the marks. In case this is not that clear, please mostly just show that is negative 1 over 4 comma negative 25 over 8. You just want to prevent losing even 1 mark or 0.5. That is so big. Now if the question said sketch the graph of f of x in absolute bars, remember you don't need to have the negative portion, meaning that instead of you having this your graph cutting at negative 3, you will not have this negative 3. Okay, so the graph is going to tend this turning point that you are able to see. You are going to change the y value, like the y value is always supposed to be positive. So instead of it being negative here, it's going to be positive. So we're going to have negative 1 over 4 comma positive 25 over 8. So if 3 is here, that means that the turning point is going to be approximately here, and instead of you having this negative 3 as a y intercept, is going to be positive 3. Is going to be here. So this graph is going to tend, it goes like that, and then it comes like that, you go there. So that's how you're going to draw it. You go down like this, and then you go up, it tends like that, and then you again go up. The portion which was down is going to be reflected up. That's the meaning of absolute value. So you don't want the negative portion. Okay. We can look at the last question here. Consider the quadratic function f of x, which is x plus 2, x minus 6. We also want to express it in the form f of x is equal to ax plus p squared plus q, and also do the same with the sketching. Now, since this one is in a factorized form, we need to expand. So that is going to be x times x in the other bracket, that is x squared, x times negative 6, that will be negative 6x, and then 2 multiplied by x, that is going to be positive 2x, and then 2 multiplied by 6, that will be negative 12. So this is going to give us x squared, negative 6x plus 2x to be negative 4x, then minus 12. And then since this is already x squared, the number in front is 1, we'll just go direct and write x instead of x squared, and then I'm going to take the half of 4, that is a 2. I'll square this. I always subtract, and then I get this number here. I square it. 2 squared, that will give us a 4, and then I write a negative 2 by the end. So this is the same as x minus 2 squared minus 16, meaning that the turning point for this function is at positive 2 comma negative 16. Now to find the x-intercepts, where the graph cuts the x-axis, We know that that happens when y is equal to 0. For this one, I'm just going to get this one since it's already factorized. It's going to be much easier. So that is x plus 2, x minus 6. I'm going to equate it to 0, meaning that x is going to be equal to negative 2 or x is going to be equal to positive 6. And then to get the y-intercept, which happens when x is equal to 0, is just a constant. Just go in the function where there's export 0. So y is going to give you, where is that constant? A constant is here, negative 12. Now we can sketch. So x values there and y values here. So for this one, we can see x, we have got a positive 6. Let me say a positive 6 is going to be here. And then let me say a negative 2 is going to be here. Okay. And then we have got negative 12. Let me say negative 12 is going to be here. And then we have got the turning point is at 2 comma negative 6. Positive 2. Positive 2 is going to be somewhere here, comma, oh, this is comma negative 16. So I can extend this. Let's say negative 16 is going to be somewhere here. So the turning point is there. You know the graph is supposed to cut through here, supposed to pass through there, and then it's supposed to also pass through here. So the sketch, the graph is going to move, go like that, and then it's also going to move like that, supposed to pass there. Okay, so meaning negative 2 is supposed to be here. Now please take note that you will not always have x-intercepts. As I said, if your turning point is here and then the graph is going up like this, you will try by doing all things, you will not find the x-intercepts. Why? It will be giving you a square root of a negative number and you don't have. So meaning that if the question was find the absolute value of this function, like sketch the absolute value of that function, you are going to have positive 12 and then positive 16, meaning that the turning point is going to be here and then the graph is going to come and cut here. So the graph was supposed to be refracted going up like that, and then it continues to go up there, and then it also continues to go up there. So that is how it would have been if it was for absolute value. So this is how you get to work out sketching of quadratic functions and completing the squares.